first speeding ticket documented by a radar reading was issued by the state of Connecticut in 1948. Today, experts estimate that 60,000 police radar units are in use across the nation's highways. These units assist law enforcement officials with the issuance of more than 30 million speeding tickets every year. Historically, radar's biggest advantage was its ready acceptance in most courts, which considered it prima facie, that is, on the face of it, evidence. Radar readings were virtually an unarguable proof of guilt, and radar-supported speeding arrests enjoyed a 99% plus conviction rate. Today, however, radar has come under fire. Through coverage in the broadcast media and popular press, millions of Americans learned of hearings where expert witnesses testified about potential sources for radar error. Through this coverage, drivers heard about panning errors, batching errors, and shadowing errors for the first time. In one sensationalized television report, viewers were shown that even stationary houses and trees could break the speed limit according to radar readings. Law enforcement agencies disputed these findings, showing that these effects were caused by careless or deliberate misuse of equipment. Some of the so-called expert witnesses were employed by companies that manufacture fuzz-busting and radar-detecting equipment. Of course, they had everything to gain from discrediting the use of radar. Law enforcement agencies have reaffirmed their belief that police radar is an effective enforcement tool. As with any tool, radar requires that its operators receive training so that it may be used properly. Operators must be knowledgeable about radar's strengths and limitations in order to use this enforcement tool wisely and effectively. Police radar can and does produce false speed readings. Precautions can be taken in order to recognize these signals. First, the individual radar unit should be checked to ensure that it is functioning properly. Once the individual unit passes inspection, the operator must avoid making errors when using it. The most common errors associated with the use of traffic radar units are 1. Overlooking the cosine angle factor, 2. Batching errors, 3. Shadowing errors, 4. Panning errors, 5. Scanning errors, and 6. Interference from other sources. Let's examine how each of these errors occurs and discuss how they can be prevented. First, the cosine angle factor. A false reading may occur when the radar vehicle and the target vehicle do not approach each other along a direct straight line. Often called the cosine error or the cosine angle effect, this error occurs when the antenna is not properly aligned with the approaching target vehicle. When in the stationary mode, if the radar beam is transmitted at an angle to the flow of traffic, the speed displayed by the radar will be lower than the true speed of the target vehicle. Angles of less than 10 degrees generally produce deviations of less than 1 mile per hour. However, as angles and speeds increase, so does the amount of deviation. When operating the radar unit in the moving mode, it is possible to produce the same cosine angle effect. In this mode, the radar may display a lower than true patrol vehicle speed, which could result in a higher than true target vehicle speed. The cosine angle effect can be completely eliminated by properly aiming the radar antenna and by comparing the patrol car speedometer with the patrol vehicle speed displayed by the radar. Radar training manuals advise operators to avoid using radars where the direction of travel is greater than 12 degrees from the center of the radar beam. A second error that can occur with radar usage is the batching error. This type of error can occur when either the patrol vehicle or the target vehicle suddenly accelerates or decelerates. Because the patrol vehicle's speed is slightly damped to avoid random fluctuations, sudden changes in speed, such as slowing down abruptly in anticipation of turning to give pursuit, may confuse the radar unit. This can cause the unit to add several miles per hour to the target vehicle's speed, or it may fail to subtract enough from the patrol vehicle speed. Batching errors occur in the moving mode only and can be eliminated by normal acceleration and deceleration of the patrol car. A comparison between the patrol vehicle speedometer reading and the displayed radar speed for the patrol car will also prevent the error. Shadowing errors are the third most common type of error associated with radar use. Shadowing occurs because of moving radar's tendency to lock its apparent ground speed to a large moving object rather than to the ground. Shadowing errors occur when the patrol vehicle is moving rapidly and closing in on a large vehicle, such as a truck or van. It is possible for the radar to compute the patrol vehicle's speed from the closing rate between it and the larger vehicle. This causes a lower than true patrol vehicle speed and, in turn, a higher than true target vehicle speed. This problem can be identified and corrected by comparing the patrol vehicle speedometer reading with that of the radar patrol vehicle speed reading. In addition, a more gradual approach to a larger vehicle will prevent this circumstance. Finally, the officer should use his or her own powers of observation and estimation to avoid shadowing errors through proper development of tracking history of the target. Panning errors occur with two-piece radar units and are caused by pointing the antenna at the readout display box. Most moving radar is built as two-piece units. If the antenna is pointed at the readout unit even momentarily, an error can result. This often produces readings in excess of 100 miles an hour of the target vehicle. Proper placement of the antenna should eliminate panning errors. Scanning errors are caused by rapidly sweeping the radar antenna through an angle across the ground or across a large stationary object. When the radar operator moves the antenna too quickly, varied reflections can cause the radar to display readings that are not those of the target vehicle. For example, some radar units with handheld antennas will pick up speed readings proportional to the patrol vehicle's air conditioning or heating fan if the antenna is scanned across the dashboard. Scanning errors can be prevented by mounting antennas at fixed positions. Errors caused by interference. Errors in readings can occur when virtually any source of electromagnetic interference is close by. Errors caused by interference are often called spurious signals. They usually last no more than a few seconds and often occur when there are no cars in sight to produce legitimate readings. Most true target vehicle readings are strong enough to override these spurious signals. Man-made products that can cause interference include emitters such as radios and CBs, televisions, fluorescent lights, radars, X-rays, power lines, transformers, and patrol vehicle fans. Natural causes for spurious signals include sunspots, magnetic fields, lightning, some forms of vegetation, and rain or snow. Other types of spurious signals or interference associated with incorrect radar readings are the power surge effect. This occurs when turning the radar on and off. The Nichols effect. Guardrails and bridge railings can interfere with accurate radar readings. The billboard effect. Large signs or billboards may affect radar readings. Jamming devices. Radar jammers cause radar to display inaccurate speed readings or no speed readings at all. They are illegal devices. Many other products are currently used by motorists to avoid speed arrests. When the trained operator is alert, the devices are often recognized. Good observational procedures and the use of speed estimation to develop proper tracking histories will help the trained officer avoid problems brought on by such devices. Because the reliability and use of radar speed measuring devices is becoming closely watched, not only by the public, but also by law enforcement officials, it is important that those who use radar understand the limitations and functions of the equipment. Trained officers will be able to avoid making errors associated with its use and will be able to make sound and visual observations that affirm radar decisions about speed measurement. As Judge Alfred Nesbitt declared in Florida's Dade County courtroom, the function of the traffic court is to convict the guilty, acquit the innocent, and improve traffic safety. not to be merely an arm of any revenue collection office.
The next case on the docket is the State versus Paul A. Brainless. Is the State prepared to begin?
Yes, Your Honor.
Approach the bench, gentlemen. Is the defense ready?
Yes, sir, Your Honor.
The charge against you, Mr. Brainless, is speeding 70 miles an hour in a 55-mile-an-hour zone, which is in violation of State Statute 56-5-1520. What is your plea?
Not guilty, Your Honor.
All right, are all witnesses in this case present?
Yes, Your Honor.
Would all witnesses please raise their right hands? Do you solemnly swear that the testimony you're about to give is the whole truth and nothing but the truth, so help you God?
Yes, sir.
Your Honor.
Officer Smith, please present the case for the State.
Thank you, Your Honor. My name is Robert Smith. I'm a certified police officer in South Carolina. I'm a patrolman assigned to the traffic division of the Aiken Police Department. My jurisdiction is the city of Aiken. As part of my duties for the past year, I have operated a police radar. I have successfully completed a basic training course for radar. I currently hold a valid radar operator's certification card issued to me from the Law Enforcement Training Council in Columbia, South Carolina. At this time, I would like to introduce that card, Your Honor, for the record. On the afternoon of September the 1st, 1982, I was operating a radar check on Route 90 near the intersection of 787 in the city of Aiken. The radar was a Doppler radar manufactured by Custom Quality Electronics Incorporated. The radar was operating in a normal manner. Test checks that I performed at the very beginning of my tour of duty at 2:15 p.m. that afternoon showed the radar to be working correctly, and again at the end of my tour of duty at 9:20 p.m. The test I performed to determine the radar working correctly were the tuning fork test, the internal and the external calibration test, and a run-through performed by another patrol unit. These tests indicated the radar was indeed functioning correctly. This time, Your Honor, I would ask that you qualify me as a witness, further permit me to testify in this case.
Officer Smith, I find at this point that the radar was operating properly and that you're a certified operator. Now you may present your testimony in the case.
Thank you, Your Honor. At approximately 4:25 p.m. on September the 1st, 1982, I observed a red Ford two-door Mustang, South Carolina license plate SOC 101, later found to be driven by defendant Paul A. Brainless. I was observing this vehicle approaching from the east on Highway 90 in my jurisdiction at what appeared to be a high rate of speed. Observations of this car first occurred some 1,500 feet from my patrol unit and continued for approximately 5 seconds. At that point, a stable radar reading was obtained on the defendant's vehicle. The speed was estimated by me in visual observation and determined to be 70 miles per hour. The posted speed limit at that point on Route 90 near the intersection of 787 is 55 miles per hour. I then fell in behind the vehicle and paced this vehicle for 1/2 mile. The vehicle continued to travel at 70 miles per hour. I turned on my blue light. The vehicle then pulled to the side of the road. I stopped. I proceeded up to the vehicle where I found the driver of the car to be the defendant, Paul A. Brainless. I issued a uniform traffic ticket to Mr. Brainless for driving 70 miles per hour in this 55 mile per hour zone. I returned to my patrol unit and went back on patrol duty.
Thank you, Officer Smith. Your testimony is now a matter of record. Mr. Brainless, please present your defense.
In any radar speed trial, whether the officer is prosecuting his own case or has the assistance from the solicitor, several critical points must be established. First of all, we must show that the accused is the driver. We need to identify the stopped vehicle as the violating vehicle. Be sure that the location of the stop permits vehicular access by the public. Ensure that the violating vehicle speed was in excess of a specified speed, whether posted or not. We need to point out that the radar was operating properly, the accuracy of the unit had been verified, and that the radar operator was both qualified and trained. Emphasize that a visual observation of the violation was made as well as a visual speed estimate. One final point, be sure that the proper records were kept concerning this violation. In the previous testimony, all of these critical points were established.